Hi everyone, welcome to another episode of another sustainability meetup under Blue Cities Network. A quick introduction to Blue Cities Network and myself, Saurabh Gupta. I'm the founder and CEO of Earth 5R. It's an environmental organization that is based in Mumbai, currently operating across India, and we operate in 65 countries around the world. And Earth Fiber is an organization that is working into. So we have got two projects. One is Blue Cities Network, which is urban sustainability project, and we also have Circular Farms Network, which is rural sustainability project. So we have two types of. So we are dealing with both rural as well as urban network. And the purpose behind starting Blue Cities Network was very simple that there are a lot of innovators in the urban sustainability space, but everybody has their own solutions and people are working in silos. They have their own network, they have their own ecosystem, and there are a lot of innovative solutions which is not reaching to everyone. So the idea was to create a network where we can share ideas, solutions, and also benefit from the network effect, share our work, and find even investors and customers and partners. So that is why Blue Cities Network was started. Blue Cities Network is all about regaining the water bodies in the city. Although, because water bodies are actually converting to black or gray in the cities, whether it's river or lakes or ponds. The idea is that also that the color of the water is also indicator of sustainability in the city, the way solid waste is managed, the way pollution is managed, the way resources are managed. So Blue Cities Network is not just about rivers and lakes, but it's also about making cities more sustainable and more livable. Today we have a few speakers. One is Kunal and Avdhut from CE Pune, and we also have Professor Shukla from IIT Bombay. So we would like to invite to start with Kunal and Avdhut. Would you like to start with your presentation, Kunal and Avdhut?
Yeah, fine. Avdhut is joining in a second, but I will just start screen share then we
Yeah,
can.
yeah, sure.
Yeah, I hope my screen is visible.
Yeah, it's visible, Kunal. Right.
Yeah. So, first of all, thanks, Saurabh, for having this space. And as you mentioned, really everyone around is working on silos, and good to have a common platform where everyone can share each other's learning and work together. So, thanks for that space. So, here today I am joining with my friend Avdut, which as an introduction, we both work with the Center for Environment Education and looking for urban issues basically on solid waste management, mobility, and citizen participation and environment. So we would like to share some our circularity assessment which we have done in three cities: Pune, Surat, and Mumbai. So
So,
circular,
Kunal, before that, could you introduce CE work a little
yeah,
bit? Yeah, because a
yeah.
lot of people are not aware about it.
Yeah.
Yeah.
So, Center for Environmental Education is uh, uh, established and founded by Ministry of Environment and Forest as Center of Excellence. And we means like our head office in Ahmedabad, but we almost work in 40 places in across India on various issues like school. We deeply work in the school education system, but as we have right now we are also working with lot of municipal corporation, various stakeholder, and some state project regarding the solid waste management, mobility, and citizens participation kind of thing. So that is landscape of working. Yeah. Mm. I could share link here, so interested can just have a more information regarding Center for Environment Education. So, in the today's space, we would like to take an opportunity to talk about circular assessment protocol, which we have done in Pune, Surat, and Mumbai. So, circular assessment is one of the attempt where we have tried to understand the plastic, litter leakage in a 360-degree kind of manner. Here we have focus on the methodology where we can document the small litter which is lying on the road and which is very vulnerable to go in the environment like river system, water system, and not able to address in the sweeping. Like sweeping cannot catch them, but more vulnerable into environment. We have also understood the inputs like which are the plastic packaging material in available in shops, how much quantum, particular packaging material nature of that. We also had a various stakeholder discussion start from waste picker, informal sector, the stakeholder which working in the cities, and that way we have understood. We also focus the solid waste management of particular city and what is happening to the waste like end of life cycle. It is getting recycled. It is
Alpegante ఏసై విజయం
yeah. So it is whether
నేను
it is
కిందకి వెళ్ళి
uh, okay. Yeah.
Yeah, please carry.
Yeah. So, as you know, the mapping,
Hmm.
documenting litter is very critical task due
Hmm.
to its nature. Here we have used the debris app, which gives us an opportunity to document very small item which we can see by our eyes and
Hmm.
document them. So we have
Hmm.
used a particular app in which we have documented. Here you can see that how many item we can document were able to document in Mumbai's Brown Mumbai Municipal Corporation and for others. So we have used this tool. So this is tool developed by the New Material Institute of Georgia, and
Hmm.
we are implementation partner for these three cities to try out this study. So I will just share the some methodology in which we have done like let's say Pune, Surat or something. We have
Okay.
identified the uh, quadrant which is 1 kilometer by 1 kilometer, and in which we have identified a small quadrant which 200 by 200 meters, and which in which randomly we have picked the pocket, and each pocket we have if there is one road going on the 100 meter road. So we have only studied the 100-meter road on side of footpath or walking spaces, and which for every city we have documented 27 randomly selected places as per the density of cities like low density, high density kind of things. This which we have documented with the help of marine debris app, and along with that we have talked with various shopkeeper, understand the consumer behavior, the available product, the packaging material, and kind of. We also discuss, had a discussion with informal sector, how much the way the challenges they are facing in the sector. So that is a type of methodology which we have tried to understood, in which we all this is available in open source. I could just share the link after the. Yeah, so Avdut is just sharing the link. And what is common thing in like Mumbai or Pune or Surat, we have find that tobacco sachet is one of the top most litter item which is getting in the lying on the road or getting in the environmental kind of thing. And obviously the tobacco packaging, plastic food wrapper, cigarette, plastic bottle cap, these kind of material which we have find majorly in the cities. I will just give this space to Avdut, so Avdut could add in our learning part. Yeah, Avdut, could you please help me to yeah.
Hello. Hi. So mainly, as, as Kunal explained, it was mainly to track the which are the solid waste items, litter items, which are escaped from the formal collection system mainly, and it also includes plastic. But apart from that, everything. Maybe it could be also biodegradable products. It could be any other paper, or etc. So those we tracked. That was a one part of it. The another part was a stakeholder interview. So it was kind of a snowball methodology. We contact one person and he leads us to another person who basically works in the solid waste management thing. He could be it could be in the processing, it could be in the collection, it could be in the informal sector, it could be municipal officials, everyone who is rather connected to solid waste management in some way or the other. That was another part. Third part was the actually to understand what kind of a you can say items which are sold in the plastic packaging. As you can see on the screen, it could be chips, it could be beverages, it could be also tobacco items, and it could be also you can say restaurant packaging things. So we purchased these products actually, and there was a kind of analysis of these products. So where these are manufactured, what their parent company. So you can see the map on the screen, map of, I think this is a Mumbai report. Okay, in Mumbai, whichever the you can say convenience item we had sourced from the shops, where they came from. So you can see all over the India these packagings are coming, and where the parent company's location. So we mapped those also. So this was one of the parts. So first is a marine debris tracker through which we track the litter on the street. Second is a stakeholder interview, and third was this study of the packaging items in the city, which are mainly you can say popular packaging items. We choose three from chips, three from beverages, three tobacco items, and some kind of a restaurant packaging things. So yeah, Kunal, you can continue.
Yeah. So, just to end here, like we have a detailed project, understand, I mean, the output for this circular assessment city for Pune, Mumbai, and Surat. We have a separate recommendation on the basis of study, but this space, due to time constraint, we thought we just focus on methodology, and we will find another space or something to, discuss about detail in one of the cities kind of. So, thanks, Saurabh. We will stop here, and if there any question, then we can, of course, discuss on that part. Yeah.
Although this is a very interesting study, in fact, we would like to know more if you have more to share.
Yeah, just to add again, like all this study, on the basis of that, we have developed the project profile, the city profile, and city recommendation and project
Hmm.
statement, which has been communicated to respective solid waste management of authority
Okay.
in these cities, and we have developed the ideas of project like implementation ideas which we can cities can run to address the solid waste management. So that is also available, but that is openly available in the open platform. So we can share link for those also.
Yeah, yeah,
But we'll
sure.
stop here to we thought we should share only methodology, and then we can share the learning and other thing in. Yeah.
Okay. So just want to understand few things. One is like in the terms of parent company, as the maps can show, there are a lot of parent companies are within India, and a lot of them are in Europe and US, right?
Uh, yeah, yeah.
Okay. So for example, which companies were from Europe and US?
uh, a detailed study of it might be from some of the item like tobacco or chips or something like that. So here we have just represented the all data, uh,
Hmm.
and the database is available detail in the report, like which type of
Okay.
species is available. It's a broad Excel sheet of 1,000 item kind of thing, so it is there. But yeah, just to
Yeah, the
represent
purpose of
that.
asking this
Yeah.
question is to understand the behavioral pattern, the consumption patterns, because what happens is that when the purpose of doing this study ultimately is to create a behavioral change and awareness. And for that, it is very important to know that what kind of consumption pattern. So I'll share some like it's a very relevant study.
So,
We also conducted something like study like this 4 years back across the country. It was conducted in most of the cities like Goa, Pune, Mumbai, Bangalore, Delhi, Jalandhar. It's pan India, like something like we studied around 100 plus cities across the country with thousands of volunteers from Earth 5 from these locations have done this study, and we have like very broad study. So what turns out that a lot of the reason is that, we why until unless we don't understand that why a litter is produced, what is that behavior that leads to the litter, and what kind of, like for example, we understand that you have done it on the pavement sides, right? What we did was we also did study on the lake sides, river fronts, because as we have a lot of interest in the water bodies. So we did a study on the beaches also, and public spaces like parks and public spaces. So what turns out very interestingly, which is different from what you found, which is why I wanted to understand this thing in much more deeper to debate about it, is that what we found that in our study there was a lot of multi-layer packaging, particularly like things like Amul, milk packets. There was a lot of Tetra Pak, a lot of Tetra Pak. I'm not seeing Tetra Pak in this, but Tetra Pak was, I think, the third biggest contributor to solid waste in public spaces, like, Appy juice and, these all different juices, small cartons of juices, then milk cartons and different types of. Then we also found a lot of products like these kurkure and these kind of things. Uh, on lakes, we found a very particular pattern in all the lakes, which was whether it was in Bangalore, it was Powai Lake in Mumbai, and many lakes. We found that a lot of birthday celebrations are happening around these places. So people carry, these Monjanis. Monjanis boxes were one of the bigger ones because it's affordable also, and they have a lot of branches. So people who would have those plastic spoons, cutleries, these cake boxes, then the layer that you have below the cake on which the cake is kept, it is also kind of between paper and there is a layer of metal also on that, aluminum foil also. Then there was these cold drink bottles like soda drinks, Pepsi, Coca-Cola, and Thumbs Up, 7 Up, these kind of bottles, beer bottles, a lot of beer bottles and cans. So this was one of the major ones. And after that, what we did was like the next step after the study was, since now we are understanding there was a pattern, so we started reaching out to the nearby areas like schools, colleges, and even residential areas, and where we showed the study that this is what turns out, and this is what is happening. And we wanted to do the reverse, because we wanted to show them that this is a typical behavior which is leading to this kind of waste, and if we want to prevent it, what we can do. And this entire thing was very impactful also, and it helped us also to modify the way we're doing our programs. So that is why I asked this question that,
Yeah, yeah. Yeah,
yeah,
so
that,
I think difference might be, matlab, here we are just try to if you see the color, we will just try to in infographics we have tried to share the beverages and candies, whatever the item
so
which
these
we.
colors are for different types of
Yeah, yeah,
items.
it's mentioned on the below, like if you see the
Okay,
colors,
yeah, yeah, right,
yeah.
right,
So
right,
and
right,
I
right,
think the difference which you have studied and asked is a methodology part. Here
right.
we have tried all across the city, all the municipal boundaries, and
Hmm,
we have mapped the density and
hmm.
it is equal representation to across city,
Yeah,
because
yeah.
and the time which we have done is after sweeping, like once the municipal sweeping is happen, and
Okay.
after that time, after like some like 2 hours, 3 hours, something like that, we have did that study. So we have just tried to follow a particular methodology, and due to this, we haven't found a large item which has a value like Bisleri bottle or
Because rack pickers
yeah,
might have already
yeah,
picked it
yeah,
up.
yeah, and that is the
Yeah.
whole objective is that to understand the nature of litter, leachate, which leak.
So you mean to say that after, so whatever
Yes.
is of low value, which is left
Yeah,
over.
after the low
Okay,
value,
got it, got
after
it.
the sweeping, and which is leakage is getting in the small
Correct, correct.
it might not be in getting
Yes,
particular
yes.
leveler, but in the small water streams, drainage
Hmm.
means whatever the our sewage treatment or whatever the water flow, we have just tried to understand
Correct.
city scenario, because we want this to be as solid waste management of city kind of
Correct.
understanding. So that was the, I think the purpose and methodology is a bit different, but yeah,
Very
good to
good point
understand
actually.
from
Yeah,
your
good
end.
point actually.
Yeah.
Also, we found a lot of cigarette butts everywhere,
Yes,
like
yes, that is
large
very true.
volumes,
Yes,
because
that,
there's no value in it. So
yeah,
the
yeah,
rack pickers will not, and even what you're saying, gutka and all these tambaku packets also don't. It's very difficult to process
yeah,
and collect, and it doesn't carry much of weight.
yeah.
So yeah, that's
Yeah, and the particular talking about the gutka, like in Surat, we have found the small rubber. There are many rubbers in our study, and
hmm.
we realized that the nature of gutka in Surat, like they have some kind of
Yeah,
where
right.
it's getting used for packaging something and
Yes,
small
yes. It's
sachet.
handmade.
Yeah, handmade kind of thing. And
Yes.
across there are many brand like Vimal, one of the brand which is higher in across all cities, and
Yeah.
the
The same problem in Nagpur. They call it
yeah.
kharra.
Yes, kharra, same kind of thing. So
Yeah.
this is very vulnerable again when it comes to, uh,
Yeah. So you'll
uh,
find different patterns in different city,
yeah,
different kind of.
yeah, in the
India is
city.
very diverse.
Yeah. So
Any,
yeah,
yeah,
everything has a detail in the report, but we thought we just use this space to share
sure,
methodology.
sure. Thank you
But
so
we
much
can
for that.
definitely, yeah.
When we publish story on today's podcast, when we publish report, we'll pick up this study that you have shared and we'll elaborate on that as well. You're mute, Kunal.
Yes, yes. I will just stop shop stare. Uh,
Yeah,
yeah, and thanks for an opportunity. Yes,
yeah.
I will stop.
Any questions from the audience?
Maybe I'll ask one question if there is a time.
Yeah, please go ahead. We have time. Yeah.
Sure. So, Kunal and Saurabh, it looks like you both have done similar studies. So, I was wondering, because I come from the technological background, and for us, raising a problem or creating awareness is not enough. Ultimately, you have to propose some solution as well. So, whenever you see a pattern or whenever you see, okay, high value, low value, ultimately there is some problem, and so you understand the problem well, but do you also provide what could be the alternative resolution or solution? And if you do provide, that's what it looks like that you're saying, then did you do a follow-up study on that? Okay, yeah.
Yeah. Just to answer that question, all these circular assessment help us to design a city-based project opportunities, which we have done for 3 cities, in which we have identified that these are the key things you should do, a city should do along with the stakeholders. So we have done a very detailed, like if we are proposing some solution, so that solution particular timeline, which are the particular stakeholder in which you should do. And even going ahead, we also found some support for some ideas, like in Surat we got some support for school based education, which we have done with the 5 school for solid waste management, school aspect. And this year again we got this opportunity for 8 school kind of. So it is truly from start from understanding the waste which is lying on the road to address, and having that idea converted into action and implementation kind of thing, which we are able to do in Surat. In Pune, we have done same pilot regarding the informal sector, like scrap store and something. But somehow that was not. We'll say we might take some time to implement that. But we have done this that. And Mumbai also we have done a stakeholder round of 40 driveway centers. As you might be aware that Mumbai has a many driveway centers, so we could have some dialogue with the municipal authority in some time kind of thing. So 3 cities has a different output. In somewhere we are try to implement at the best, and somewhere we have stuck with just idea, and somewhere we just kind of somewhere in the between. So yeah, so that was a nice journey to, yeah.
Sure, thanks.
Professor Shukla, just to add to that, so it's a very good question. So what happened that this entire study we did was was during COVID and post-COVID also we did, and pre-COVID and post-COVID we found differences. So there was a publication in a newspaper also about this study that during COVID time how the multi-layer packaging plastic consumption suddenly saw a spike, and this was study widely published in newspapers, earth fiber study. So this was one. Now what happened after that, since we're talking about follow-up, we were inspired to design, obviously we designed an app eventually, earth fiber app. So we designed a module within the app. Now using that module, what people are doing, citizens are doing, it's part of thousands of interns and volunteers every month who join on the platform. What they do is like, this is one of the essential modules for them, where they walk for 1 kilometer in the locality. So we say that you should walk. So it's a bit of an exercise for them because people are sitting on couch and just browsing phone. So they have to walk for 1 kilometer, and it tracks their distances, and it makes a map on the phone in their portfolio. And they also do a study, field study, in a particular location, and they identify all the waste that they could find, and then they in the app they just put, it will ask you that what did you, how many numbers of waste did you find, and how much was Tetra Pak, how much of this, and no metals and everything. So you categorize, and on the dashboard we can see region wise, city wise, pin code wise, that this much of waste was found, and this is the different types of, this is a granular level. So we get the entire data that this is the percentage of waste in Mumbai or Pune or in this particular pin code. So you can see it on a dashboard. So this is, and this study is ongoing. So it's as of today also, people are doing it on the app, and we see data on daily basis.
Wonderful.
So any more questions from the audience regarding the CE's presentations? So if there's no other, then we'll take it to Professor Shobha Shukla from IIT Bombay. And Professor Shobha Shukla, if I don't know whether you remember, but we met in Bangalore in United Nations climate change meeting also.
Right.
Yeah, we were together part of a group also. So after that, I've been trying to get in touch and somehow trying to meet, but it couldn't happen. Sometimes you were busy, sometimes I was busy. Although we are very nearby, we are both in Powai. But it's great that we got this opportunity today to have you and listen to you and have your presentation. So please go ahead and present your slides and give a bit of introduction about your work and what you're doing in this field of sustainability.
Sure. So let me share my screen. I quickly made something because somehow I had a very busy day today. Is my screen visible?
It's yeah, it's visible.
And the floaters, let me get rid of floaters. Okay, let me put it on the full screen mode. Okay, still I need to get rid of this. Right, floating. Okay, wonderful. So I hope now my screen is visible.
Yeah, it is.
Okay, wonderful. So I'm Shobha Shukla. I'm from Metallurgical Engineering and Material Science Department at IIT Bombay. I'm also representing my research lab, Nanostructure Engineering and Modeling Lab, as well as I'm also heading the Water Innovation Center uh, at IIT Bombay. It's a center so basically we are the lead institute, but there are 4 institutes that are involved in this center: IIT Bombay, IIT Hyderabad, PDPU Gujarat, and NCL Pune. So today, whatever I'll be showing, it's mostly the activities that have been performed at IIT Bombay in my lab. So I'm more of a trained photonics person. I use laser for like different types of patterning and more on the photonics side. But when I came back to India back in 2012, I wanted to contribute directly also to the society. So it's something which I thought like there are multiple questions that people do ask what IITs are contributing. So whenever there is a high-end contribution, it's not very direct contribution to the society, and people start to raise some sort of fundamental or somewhat naive questions. So I thought it's a good idea that I should diversify also myself. And having worked on different chemical processes, I started working on graphene, which was a hot topic during my PhD. So I came back to India, found out different interesting ways of making graphene, and specifically my focus was not to make graphene from the expensive method, but from the inexpensive methods. So we developed lots of protocols. So in our lab, what we do is we use a holistic approach basically. So I'll come to this holistic part in the little later, but what we do is we synthesize lots of material, we pattern it because ultimately we make lots of sensors. So patterning work is goes into the photonics domain as well as more on the developing different types of microsensor as well as generic sensors. I'll show some sensor work today.
Professor Shukla, just a request that a lot of our audience, which is not present today, I mean, but because this talk will go on YouTube,
Mhm.
and then there are thousands and millions of people will eventually read the article as
Mhm.
well as so a lot of them are aspiring sustainability, students or people who are in corporate world, but they want to start businesses. So for
Mhm.
them, these technical, if you can simplify the terminologies in a way that, common man who doesn't
Sure.
understand technology, it will be very helpful. Thank you.
Sure,
Yeah.
definitely. So I'll try to talk in layman terms.
Mm.
But
Yeah.
so the whole goal is to develop a kind of a graphene. When I say graphene is, you can think of it's a carbon material. It's a pure carbon material, but more on the
Okay.
sheet form.
Sure.
So you can think of this is one of the wonder material that shows lots of interesting properties. But typically, it's difficult to synthesize, and even if you synthesize it, the cost goes high. So what we have developed a bio-based protocol for making this in a very inexpensive manner. And then, having done that, so that is one thing that I have said. We have made other carbon material. Why we are sticking to carbon? Because that is what the nature's way is. Nature
Mm.
only work on CHNO, right?
Okay. And
So
why? And why?
that is what the bacteria also degrades every difficult or different materials into the CHNO form because that is where it can reintegrate into the system, and
Okay.
then you make another material.
And
So
that's a building block of nature
that's
also.
that's a major building block of the nature. So
Mm-hmm.
basically, carbon, hydrogen, nitrogen, and oxygen. If
Mm.
you see, these are the different composition in different ways are present in Kshitijal Pava Gagan Samira, in all
Mm.
the five Panchabhut that you are talking about.
Mm-hmm.
So, and that's the basic life sustaining environment or life sustaining uh, world that we are having. And because of the imbalance of these materials, that we are having lots of problem. You might be hearing about the carbon capture technologies that
Mm.
are coming, carbon emission. So because of this imbalance, but what I'm trying to say is plastic is one of the example that people were talking about earlier as well. So it's a very long chain polymer. And
Mm.
degrading it is a major issue. Ultimately,
Okay.
where do we degrade? We degrade it to again the simplistic chain. So best is we degrade it to the carbon, basic carbon isn't. Otherwise, into a very simple chain, which can be digested by the bacteria and other things. Anyway, coming back to here, so this slide was more for technical thing, and then I wanted to show the different technologies that we have developed. That is what the ultimate goal for this talk. We have like made lots of materials. Zero dimensional is something which is like a kind of a dot. One dimensional is something which is like a rod. Two dimensional is like a sheet. So different sort of materials provide different information or different applications. So that is what we do. We use laser for making sensors in a very small area. I'll show one application there. Then we do lots of drug and contamination detection, antidote delivery. As I mentioned, we have made graphene using a very inexpensive method. Graphene shows a very good hydrophobic property. That means it loves oil and it hates water. And that is what we can use it for different application. This is the application that we are going to show. Then we make lots of membrane. You would have been using it for all the water filtration and then some other applications. But whatever we are making, eventually we do toxicology study, because we do not want to create secondary or tertiary contamination. The whole goal is to develop a holistic approach. So that is what we do. Whatever material we do, whether it's for the photonic application or for the water application, we do all sort of studies, but ultimately we do toxicology study, and then comes to the deployment. So toxicology study also reminds me the question that was asked, the microplastics effect on the marine life and then ultimately to us. So we are working towards that goal, and I'm pretty happy that we have developed some kind of a unit where we can separate the microplastic. Actually, our focus is more on the
Really? Wow,
plastic.
that's amazing.
Yeah, I'll
Because
show you.
microplastic is
So
the biggest problem.
no, actually, nanoplastic is the biggest problem.
Yeah,
Microplastic is
exactly,
something which
exactly.
can be
Yeah,
separated physically. So
yeah.
microplastic is less of a problem. Problem is actually the nano, whenever the
Hmm,
sizes go below micron, because
hmm,
if you will use a membrane or something, it will foul the membrane immediately.
hmm,
So that's not, and so that's why the problem is not only to separate, but also degrade it. So that's why with the sensor, you have to find out what is there, what
hmm,
kind of material system or biological system or something which needs to be there to trap it. But then ultimately, nature is the best way to degrade it. There is no other way. So biological degradation is the best way. You can trap a lot, then put it into some bacterial system where, because bacteria has the only capability which can bring it to CHNO in a more nascent form. Any chemical method, it will always create secondary or the tertiary problem. So this part works well up to certain state, then you go to degradation, then whatever you degrade, you have to understand whether it really went into the non-toxic form, because many times people at this stage, trapping stage itself, start calling it that I have removed the problem. You have not removed the problem, you have just diverted the problem. It's just not in my backyard approach. So this approach we have to get rid of. So I'm sorry, I'm trying to be a devil's advocate, but this is where most of the technologies, this is where most of the solution providers are. They are not really traveling this path. And if we don't travel this path, we are creating another problem for the future. And that's never going to provide us a sustainable approach or sustainable future. So ultimately, whatever we provide, we have to look into whatever we are providing in the secondary or tertiary way, and then finally deployment has to take place. So we do some deployment, not up to the scale that you people are talking about, whatever is possible using our system. I don't know why okay, now it's moving. Yeah. So this is just to showcase different things that we have developed through our water.
In the previous slide, Professor,
Yes.
there is something about sensors. So this we understood, that trapping, degradation, toxin, and deployment. But how does a sensor function in this entire
Yes,
process?
I'll come to that part
Okay.
in a minute. Okay, so these are different technologies. This is a map of the Pavahi Lake also. As you can imagine, this was the COVID time. So there are 8 inlets that are in there. This was back in 2021, just right after the COVID. I know BMC claims whatever, and there are various other different things. I'll go into some of the technical details. But before I go, I just want to show some sensor specifically. I also thought would be interesting for quite a few. So I will go into the detail for the sensor, but just to show the kind of materials that we have developed. So this is a kind of a graphene foam that I was talking about. Oil is below, water is above. It will only interact with the oil, and it absorbs the oil almost 27 times of its weight, depending on the density of the oil. And then you can just move it. I'll show the different kinds of skimmers that we have made with that. We have some technologies which are TL5 or above. So for that, I have made some video. I'll discuss after the video if you have any question to that. I hope you can hear the voice or music.
Yes, yes.
Perfect. Yeah.
No, we can't hear the music. We can hear your voice only.
Okay. Is it better now? No?
No.
Okay, so I think it's not shared then. Okay, I'll just explain. So basically what we have developed is a water filtration unit for the arsenic specifically. So
Okay.
what we have is we have replaced one of the RO.
Yeah, now there is a sound.
Okay,
The
then
water then
let it
flows
be.
sequentially through a sediment filter, carbon filter, and UV filter to eliminate remaining impurities. A digital sensor continuously displays arsenic concentrations at both the input and output points. Additionally, a strip-based colorimetric test confirms arsenic presence as a blue color in the input sample, while no color change in the output indicates arsenic-free drinking water. This compact purification setup provides a reliable solution for arsenic-contaminated water, combining adsorption, filtration, disinfection, and real-time monitoring in a single system. Thank you.
Okay, so this was the arsenic filter that we have developed, because arsenic problem earlier it was only limited to Assam and West Bengal, but now it has propagated up to the Punjab. So we thought mostly the arsenic filters that are available in the market are for the community level, and there are no ways to even monitor. So that is what we thought, we having a technologically sound background, we will be able to provide something which is more of a personal thing, because arsenic absorption through the skin is much less. But when ingested, when it's gone into the stomach, then it creates a much bigger problem. So this was one option. The second technology is more of an integrated technology. So so mostly to address the RO reject issue. Let me run this video and then I'll come back.
Hi. This system integrates reverse osmosis and solar thermal desalination with IoT-enabled data recording such as TDS, surface temperatures, and ambient conditions using Jaltatva mobile app. Brackish water with a TDS of around 1000 ppm feeds into the RO unit. It produces 40 to 50% permeate water with less than 200 ppm TDS and 60% reject water. This high TDS brine, about 2000 ppm, is then treated in a solar still, using solar energy and a modified absorber surfaces, nano-coated absorber surface and hydrophilic condenser surface for yield improvement. The still mimics the natural rain cycle. It evaporates the brine, and the vapor condenses on a cooling surface, yielding clean water with TDS typically below 50 ppm. This sustainable process converts waste brine into fresh water using solar power. Thank you for watching. Save water.
So this technology is, it can be used in the water stressed area, somewhere more in the north side. So it not only, so you can use the existing RO, and whatever the RO reject, you can condense it. Also, the same technology can be used for generating more like a rose water or different kinds of high-end product, along with the HPLC grade water, because this is a purest form of the water that you will get. Other than that, this is a graphene foam that we have made. About the sensor, so one strip sensor that we had shown in the previous video, this is a sensor which we have developed for mercury, because India is a kind of a mercury capital of the world. You see, we used to, till 2018, we used to import, and still for the geogenic or some other reasons, India soil as well as water shows a high amount of mercury. So what we have developed is a very specific sensor, so don't go into the detail. It's lots of materials that are mentioned here to show that whatever we are going to measure is not all other, because see, chemistry wise, if you see, there are many other interfering materials that will also be present. So to show that, let's skip, because this information, and then pH is to show it works in the different acidic and basic conditions. And these are the different versions that we have developed over the years. So this sensor, what we have developed, it's a strip-based sensor. I'll show the working in the next video. And it not only changes its color, but also there is a underlying kind of electronic layer which changes, and the device can detect much below the whatever the permissible limit that is for the mercury. So ppb level detection can be done. Response time is a couple of minutes. It's very portable. It's a photoconductive device. Actually, this is a slightly old story. We have now moved more towards the electrochemical device, which is much more accurate than this one. So here what we had done was, because mercury interest was coming from so the same concept we have shown for the organoarsenic as well. But the mercury we had got interest from the Ministry of Fisheries, and there was another industry which was shipping lots of seafood. And their seafood containers were coming back because of the high level of the mercury in that one. And they had no way other than the lab-bound techniques, which are very expensive, very time-consuming. So 2 to 3 days it used to take to get to know the mercury level in if it is present or not. So what we had developed is something like a kind of a batch process. So whatever in the one cage you are seeing, there is a small dot in there. That is what the sensor is, and you just need to put one drop of whatever the plasma or blood. I'll show that part as well. And you can successively detect how much mercury, or in this case, arsenic is present. It is to showcase, I'm only showing mercury and arsenic, but we have developed the same protocol for the lead, cadmium also. So this, what this student did was he got one fish from the Powai market, and he also got lake water, Powai lake water. And so if you remember, in the mercury, the permissible limit was 2 ppb. What we have got even in this fish plasma sample, so got the blood, separated the blood and plasma, and then it's little scary. I will not voice it out. You can read it, and then you can think of it's the kind of mercury level. Not in every fish, but like quite a few showed this kind of sensor, this kind of issue. And so what we have developed is a very portable platform which can be used for quick detection of the mercury if it is present at a lethal level in the kind of water or the seafood that you are having. This is a more of a compendium of all the technologies that we have developed. I'll run that.
Welcome to the technology developed at NemoLab IIT Bombay. First one is Grey Filter. It is developed for treatment of industrial wastewater. Here you can see working pilot plant. It is highly efficient for removal of different type of dyes and organic compounds. Next is membrane for oil water separation. We have developed two type of membranes. One will be effective in oil in water emulsion. Here you can see from the emulsion, water is passing and oil is retaining on the membrane surface. Other membrane will be effective for water in oil emulsion. This will allow oil to pass through it and water retains on the surface. We have also designed and fabricated a 3D printed membrane scaffold for continuous oil water separation. It has been demonstrated during IIT Bombay Tech Fest. Next is gray foam for oil and organic solvent recovery. Here you can see its selectivity as it is passing through the water but not absorbing it. We have further designed and developed an oil skimmer for continuous oil recovery. As you can see, it is remotely controlled by providing the GPS location, and its live location can be monitored on the screen. You can also have live visuals from the skimmer at your mobile or laptop. Further, you can see its continuous oil sorption and recovery. It will be effective for recovering oil from the oil spills, even at the remote location in the sea. After completion of the operation, recovered oil is collected from the skimmer. As you can see, this recovered oil can be further used. Next is sensor for heavy metal detection. We have developed two types of sensor. One is based on chemiresistivity and other is on photoconductivity. Developed device is highly portable as you can carry it in your pocket and can be used anywhere, anytime. Its detection limits are lower than the permissible limits in the water. Here you can see its instant detection just by putting a drop of sample water on the detector strip. Next, you can see chemi-resistive sensor for lead detection. It was demonstrated during IIT Bombay Tech Fest. Next is 3D model for industrial diaffluent treatment system. Further, we have thermal desalination cum membrane filtration system as demonstrated during IIT Bombay Tech Fest. Thank you.
So here I would also like to acknowledge my funding agency. That's a very typical academic thing that you should not be presenting anything without thanking, because all the research takes lots of money, and I've been fortunate to receive support from everyone as well as from all the students because I'm mostly presenting their work. It's they who have done lots of hard work. This is something which I typically talk to the research group, maybe not relevant for this audience, but sustainability is not only the aspect that general public, but also a research group also needs to look into it, and we also have to follow whatever we preach. And finally, yeah, this is where I would like to stop, and if any questions or any discussion point that are in there, I'll be happy to answer.
Thank you, Professor Shukla. That was really amazing. We got to know some very interesting things that we would have not known otherwise. So first question is that, first comment is that I think that whether it's good or bad, but you're lucky to have IIT, Powai Lake, basically for IIT. Because it's like you can do all kind of experiments, good or bad, in that lake.
Anything, you just name it, it's there. I too agree. I
Yeah,
totally
it's
agree.
like Pandora
Somebody asked
box.
me, yeah. Somebody asked me during one of the DST presentation, and I said it's a good concoction of everything. You want it, it's there.
Yeah. And
And
on,
the good thing is, BMC claims nothing falls into it. So there is
yeah.
no one is there to contaminate it, and it just gets self-contaminated.
Yeah, exactly. And during since Earth Fire started from Powai in the early first couple of years, all our volunteers for lake cleanup were coming from IIT Bombay. So we had like around 70, 80 volunteers every weekend coming from IIT, and we used to do a lot of cleanups inside IIT, outside. Inside IIT, the biggest waste was beer bottles near the
Yeah.
lake part. Very interesting. So now, one question I have is Rohu is, I think Rohu fish, they sell in the market also. They take it out from Powai Lake. So you're saying that it is 3 times higher?
I would not like to reiterate that. It's so 3 times is lesser of
Yeah,
extent we're
it's a
talking
lot
about.
more. It's a lot more.
Yeah.
Okay. By the way, on that note, which seafood is safer to consume for audience?
Without measuring, we cannot say.
Okay.
Uh, this is the study that we are trying to perform now, not actually on the particular heavy metal, but we are performing some studies on the zebra fish.
Hmm.
So the studies that we are doing is if heavy metal goes in. So basically, not only the heavy metal, but also we are looking at the opioids,
Hmm.
how it affects, where it accumulates,
Hmm.
because wherever it accumulates, my daughter also decided to join me today.
Yeah, nice to have a.
Yep.
Yeah.
So, so where it actually accumulates and where actually the interventions are required, because
Hmm.
sometimes interventions are provided in a place where it's not the most appropriate or most efficient.
Right.
So, like microplastic, somebody asked where what happens to it, but where it is actually getting accumulated, that is
Hmm.
what is more important.
Hmm.
Similarly, so basically these are the studies that are undergoing, and there is no direct answer to it because these are kind of a new problems that we humans have created.
Correct.
No one else we have to blame for. So
Yeah.
blame to and. So microplastic, as I mentioned, the foam kind of a system, the same kind of system we have developed for the not actually, I don't work on microplastic. With microplastic, I find it's too big because microplastic by definition is in MMs. So it
Right.
doesn't make sense to provide a solution. That simple sieve will also work for it.
Hmm.
It's just the willpower that
Nanoplastic.
is needed. So
Hmm.
nano means like micron, rather real
Hmm.
micron size. That is what
Yeah.
the major problem is. But not only just where it gets accumulated and then, but how to resolve the issue. That is
Hmm.
what is the major thing. Yeah.
Okay. Next question I have for you is that this device that you have prepared or your team has created, which you said it's portable and small also. So can this device, is it available or will it be made available to the market so people can
Yeah,
use?
so we are open. So Arsenic One, we have opened our own like startup,
Hmm.
and we are in talk with some of the companies where mostly the marketing partner is them, manufacturing partner will be us.
Okay.
Whosoever wants. On a similar model, we can work on the sensor as well. For
Hmm.
Ampeda, this Ministry of something,
Hmm.
seafood, something, that is what I
Hmm.
remember now. Ampeda is the one who is after us for the mercury sensing work.
Hmm.
And so far, we have been like only thinking of providing it to them. But whosoever wants such sensors,
Hmm.
we will be happy to collaborate on the different aspects. And so, licensing the technology is something which we found is not really going to work out because these are really high-end technologies and lots of hand-holding is required.
Hmm.
So, it cannot be just scaled up like that.
Hmm.
So that's why we thought the best way of dealing, because we have lots of technologies, we have lots of, but it's like 15 years of research experience and
Hmm.
at very high level that we are willing to provide, but somebody has to walk with us and co-create.
Sure, sure. Any thoughts about your water filters? Like, is it a new version, upgraded version of water filters that exists in the market? Is it better, or will it be available for commercial
At
for
least
rest?
to the best of our knowledge, there is no personal arsenic filter that is available in the market.
Yeah,
At
yeah.
least not to
So,
our knowledge. That is one aspect, that is where we are differentiating. The second aspect that is where we are differentiating is IoT enabled, so we can check whatever the different levels that is in there. We
hmm,
also are providing one high-end solution for the arsenic detection,
yeah,
which is
yeah.
expensive if somebody has money and want to add it, but also low-end solution, which is not
Okay.
PPB level accurate. So strip sensor that which we showed in the video. So that's
Yeah,
very low and very inexpensive. It's like a pH strip,
sure.
few rupees,
Right, right,
10
right.
rupees.
Yeah,
And
yeah.
it will tell you 1 ppm and above.
Sure,
And
sure.
typically in India, the arsenic that is present is 1 ppm to 10 ppm
Hmm,
in the lower range, and some places it's more than 100 ppm as well.
okay.
Mhm.
So, why I'm asking this question about water particularly is that at Earth 5R we in our rural project. So
Mhm.
we're starting a very large scale project. We'll be announcing it very soon. So I'll not reveal the name of the partners as of now. But one of the India's largest food company and of the leading banks also which are involved. So the idea is to help farmers move from traditional farming, chemical based farming to organic farming and making it more affordable. So
Yeah.
that the idea is that 5 years down the line, we would like organic food to be more cheaper than the chemical food, which
Or equivalent at least.
logically it should be cheaper
Mhm.
than
Yep, yep.
chemical based.
True that, true that.
So that is where a big piece of water comes into picture, because if the water is contaminated, even though
Yes,
whatever seems organic is really not even
not organic.
very good. So
True.
we would like to separately discuss and chat
Yeah,
about it on a different forum, and maybe
sure.
personally we'll catch up. But we are looking for a solution because this project is very large scale and there are large funders also possible in this project.
Sure, sure. No, we are very happy. That's what we said. We are very happy to provide all the technological support
Yes,
that is
yeah,
needed, and we are open for all sort of discussion. It's
yes.
only thing which we have realized is earlier we were working more on the licensing mode,
Hmm.
but we realized it doesn't work because ultimately they don't have expertise to scale up, and then it fails miserably. So
Sure.
better we walk that path with them
Sure, sure. And
rather
that is also one idea behind Blue Cities Network is to, get to know about these solutions and
than
find partners and, take it to the market basically.
yes.
Yeah.
Yeah.
Any questions from the audience as well?
So I see one question was on the fluoride sensor. Yeah, okay. First question was the IIT Madras. Yes, Professor T. Pradeep also work on the similar line, and so our work is you can say similar, or I claim it to be better than that. And but they are more into the purification only. We are more into the sensing and purification, because we have to know what we are purifying and whether it's purifying up to the extent which we want to purify. Because lots of government has put in lots of money on the arsenic filter, that big tanks in the Bihar and West Bengal, and nobody knows whether they work or not. Even when I was talking to Assam CM when I went to G20 Tripura meeting, and that is what his major concern was, because in Tripura, not only the arsenic, but the iron is equally a problem. So, but they have put
High,
the tank,
high quantity of iron?
iron, very huge quantity of iron.
Okay, okay.
And so that was the concern that he raised. That tank is there, but it's working or not. And most of the time, it's not working because nobody is there to maintain. And
Hmm.
maintenance comes when the sensor or somebody is going to tell them it's not working. Whatever the
Correct.
output that you are getting, it's not up to the mark. So that hopefully answers your question, Anil. The second question was fluoride. Fluoride is a easy sensor to make. Fluoride problem has already been there from quite some time in the entire region, and it's much easier to provide a fluoride sensor. And if required, we can also provide. Heavy metal was more of a uh, because fluoride, it's corrode only. Arsenic or mercury, if it accumulates, it kills. So
Lethal.
yeah, it's lethal,
Yeah.
even in
Two ways
small
of
dose.
dying. Which one do you prefer?
Slow dying or the fast dying. Yeah, true.
Yes, or from the audience, any more questions? Anything else would you like to share from your experience, your knowledge, or anything that you're doing other than the speakers? Okay, since there are no questions, we would like to conclude today's session. So, so one of the outcome of this sustainability meetup that we do is that we'll publish this in form of YouTube video, and then after that we convert the entire talk into an article, and Earth 5R website we put it there, which is something called as Earth Journal. Earth Journal has 6.3 million readers from around 65 countries, so very well read and very niche audience. The audience is mostly from sustainability space. A lot of governments, policymakers, and businesses they read. So hopefully this will reach to a larger audience. So thank you so much to CE team, to Avdhut and as well as Kunal and Professor Shobha Shukla. We will please feel free to reach out to me. Whenever you have my number, and if you want any enhancement to the article, you want to provide any more content to be published in the same article, please share. And also request you to share your slides via email, so we'll publish it as well. Till then, thank you so much, and we'll reach out to you guys very soon for talking about partnerships.
Thank you everyone. Have a good night.
Thank you.
Thank you, sir. Thank you, Shobha ji.
Thank you.